All right, guys. So let's get this factoring discussion wrapped up for the day. What do you think? So we're going to end with factoring. So in a way, I've saved the best for last because I know you all are good at factoring by grouping. I said we're going to end with factoring. We're going to end with grouping specifically. And grouping is easy to tell because you look for 4 terms. But before you look for 4 terms, do you have a GCF? Shoot. I was looking at the 4, the 16, and the 4 and thinking, yeah, 4 is going to be a GCF, but I don't have anything but 1 right here. So no GCF. We've already done some grouping today when we worked on the AC method anyway, so this should go pretty fast. GCF here, 4x squared. So 4x squared times x, 4x squared times 4. Bring down the plus sign. X plus 4, there's no GCF other than 1, so I'm going to bring the 1 out. Can you see it that x plus 4 then is really your binomial GCF? 4x squared plus 1 is what's left over. This one has a chance at factoring again, but these are perfect squares, but that's a sum, not a difference. This one's done. Now, similar problem, look for a GCF. I don't see one. Go ahead and start factoring like normal. So first pair, second pair. X squared is your GCF times x minus 2, x cubed minus 2x squared. Bring down the minus sign in the middle. Between 9 and 18, 9's the GCF. You have to have x minus 2 here and a match here. Double check, that's negative 9x, yes. Plus 18, yes. Okay, so grouping is working. X minus 2 is your binomial GCF. X squared minus 9 is what you've got left over. The order of those doesn't matter. I do notice this time, though, x squared minus 9 is a difference of 2 squares. So recopy the first guy, split this guy into x plus 3, x minus 3. Now they're all linear, meaning it's x to the first power on all of them, so you're done. Sorry, it doesn't look quite as sharp on the picture. 2 more examples. All right, guys, get ready to be wild and crazy again. I have packed everything into this problem I could. It's just like Prego spaghetti sauce. It's in there, every ingredient possible. It's going to be spicy. All right, GCF. Yes, there is. Even though you might say, no, there's not. Remember, if you lead with a negative, then negative 1's your GCF. How do you manage that? You flip-flop all the signs on the inside. Now, I mean, this looks like a relatively easy problem. First pair, well, it looks like x cubed comes out, and that would be x squared in order to get x to the 5th, and then minus 4 to get minus 4x cubed. Plus comes down, and then there's no GCF other than 1. All right, so I'm going to drop it, instead of saying negative 1, I'm just going to say negative. I'm going to drop the brackets and go straight to x squared minus 4 and x cubed plus 1. Now, you may have already gone, we got your ticket, Miss Porter. We saw this early on. X squared minus 4 is a difference of perfect squares. So I'm going to say x plus 2, x minus 2. But wait, there's more. It's just like an infomercial. X cubed plus 1 is a sum of perfect cubes. So we got to get a little bi, tri, soap action going. So bi, tri, same, opposite, always positive. I told you I put everything I could think to put in this one. So the cube root of x cubed is x. The cube root of 1 is 1. First, here, first squared would be x squared. In the middle, first times second, 1x. On the end, second squared. 1 squared is just 1. This trinomial never goes again. These are all x to the firsts. X to the first problems don't go again. Whew, you're finally done. One more example. All right, guys, this is momentous. This is your last example for the week, because what we'll do on Thursday is just mix all the type of factoring so you get better at recognizing, oh, that's perfect squares, oh, that's AC method, but you won't have any other new lesson. So we're going to hover on this factoring for a while because it's so important, and you really do get better straight up with practice. All right, so if you look at this problem, you'll count and go, wait a minute, that's 1, 2, 3, 4, 5, 6 terms. Remember when I told you grouping would actually work for 4 terms or 6 terms or 8 terms or 10 terms, yada, yada, yada. Normally you're going to have 4, but I want you to at least see one that has 6 terms. You don't have any in the practice work that's on this, but I want you to have some exposure to it. So what do? You get 3 pairs on this one. First, is there a GCF? No, because with that being 1, that throws out there being a number GCF. And with that not having an X on it, that throws out there being a letter GCF. So first pair, X to the 4th is your GCF. 2X minus 1 is what's left over. Bring that plus sign down. Second pair, well, I see that 9 goes into both of them, and so does X squared. Well, it would be 9 times 2 to get 18, X squared times X to get X cubed. Oh, and then minus 1. Notice the 2X minus 1 and the 2X minus 1, they're alike. That's on purpose. Bring down your next plus sign. Last pair, 20 is your GCF, and it better be 2X minus 1. Sure enough, you do this, you'll 20 times 2X, 40X, 20 times negative 1, negative 20. So now I've got a binomial GCF. 2X minus 1 comes to the front. When I pull the 2X minus 1 out of the first term, the X to the 4th is left over. Plus, when I pull the 2X minus 1 out of the middle term, the 9X squared is left over. Plus, when I pull the 2X minus 1 out of the third term, the plus 20 is left over. Holy schmoly, Batman. This is a trinomial, and since it's X squared, double the 2, you get 4. AC method might work. So I'm just going to recopy this guy, 2X minus 1. Guys, if this is going to factor AC, the X to the 4th has to be X squared, X squared. So now I'm looking for 1 and 20, an AC of 20, and a B value of 9. Are you already thinking 4 times 5, 4 plus 5? Hey, listen, guys, since it's 1x to the 4th, I could skip doing the grouping and I could say plus 4 plus 5. If this is not 1, you can't do that. But if it is 1, that'll work, because if you go back on the part that I just took a shortcut on, if you do FOIL method, first is x to the 4th. Outer is 5x squared. Inner is 4x squared. Last is 20. And sure enough, that gives you x to the 4th plus 9x squared plus 20. And that is where we came from, x to the 4th plus 9x squared plus 20. So if you start out, if you do a trinomial AC method, if it's 1x squared or 1x to the 4th or 1x to the 6th or 1x to the whatever power, once you get your AC chart, you can just plop the plus 4 plus 5 here and here. Or if it were minus 6 plus 3, you put minus 6 plus 3. If it's 1x to the whatever on your lead term, hey, you're done, okay? We've checked our work on that one. That's a big old grouping problem. You don't have one this big later on, or not today, but you might see them later on when you get into Algebra 2B or into pre-calculus. All right, y'all. Do a great job on that last set. I believe, if I'm remembering correctly, it goes maybe 20 to 25, maybe 19 to 25, something like that. Good luck finishing it. No, no, no. It goes 25 to 30. There you go. Have a great one. I'm on Zoom if you need some help.